Welcome you all in this YouTube channel Mathemagic, and today we are going to start the uh, concept nth order linear differential equation with constant coefficient. Okay, so before starting the concept, first we'll see the basic about the differential equation. So what is in by differential equation, and after that what is in by linear differential equation. Okay, so because this is very important to understand the meaning of differential equation, and then we discuss nth order linear differential equation. So let us see, first is a differential equation. What is in by differential equation? Okay, so differential equation means what? The equation which contains what? Differential coefficient, dependent variable and independent variable. Dependent and independent variable means what? Suppose if we see the velocity. So what is velocity? Velocity is nothing but v is nothing but change in displacement with respect to time, where s is nothing but displacement. Okay, see, this s is depend on t. Here s is dependent and t is what? T is independent. Okay, s is dependent and t is independent. So therefore here same here, because the value of s is dependent on t. As time goes, displacement changes, distance increase or decrease, distance may increase or decrease. Okay, so therefore this s is dependent on t, but t is not dependent on anything, t is independent. Okay, so like this, suppose if we have the function y is equal to fx. So suppose we have the function y is equal to fx, y is a function of x. This imply what? If we differentiate y with respect to x, dy by dx. So this is what? This is the differential coefficient. Differential coefficient. Okay, so here y is dependent and x is what? Independent. Got it? Okay. Now let us see the definition of differential equation. So the definition is what? In the definition, the equation which contains dependent variable independent variable and differential coefficient. Okay, is called differential equation. See, in this equation, for example, suppose if we see the examples, first example is d square y by dx square plus 2 dy by dx plus 4y, this is equal to 0. So this is the differential equation, because these equations contain dependent variable. This is your dependent variable, this is independent variable, and this is the differential coefficient. This is dy by dx or d square y by dx square. These are the differential coefficient. Okay, one more example we'll see here. Okay, so it is d cube y by dx cube plus d square y by dx square minus 2 dy by dx plus 3y, this is equal to 0. This is one more differential equation. Okay, this is also differential equation because it contains dependent variable, independent variable, and differential coefficient. Got it? Now what is important here, one more thing to understand the nth order linear differential equation is that order and different order and degree of the differential equation. Okay, so what is in by order and what is in by degree of the differential equation? That is very important. So let us see what is in by order and what is in by degree of the differential equation. Okay, So order of the differential equation, what is meant by order? So let us consider the example first. D square y by dx square plus 2 dy by dx plus 4y equal to 0. Okay, so how many differential coefficients are here? Two. Okay, this one and this one. So this is the second order, this is the second order differential coefficient. Okay, so first one is d square y by dx square and second one is dy by dx. So this is what, this is the second order differential coefficient, second order, and this is what, first order, this is first order. So these are the two differential coefficient. So whichever is the high so the the coefficient which has the highest order, okay, the coefficient which has highest order, that will be the order of differential equation. Okay, see, this is order of this is 2, this is 2, and order of this is 1, therefore highest order is 2, and the equation, the order of this equation is nothing but what, order is nothing but 2. So what is in by order? The order of highest order derivative in the equation is order of differential equation. Got it? So see here about this equation. Okay, so what is the order of this equation? So this is the third order derivative term, this is the second order derivative term, and this is the first order derivative term. So highest order is 3, and therefore order of this equation is what, 3. Got it? Okay. Now, what is my degree of the differential equation? Degree is also important because our concept is depend on the degree. So, degree of the differential equation. What is in by degree? So, whatever the power or index of highest order derivative term. Okay, so whatever the power or index of the highest order derivative term in the equation, that will be the degree of the differential equation. For example, suppose if we take, it is d square y by dx square plus 3 dy by dx bracket square plus 4y, this is equal to 0. Okay, which one is highest order derivative term? This one. So therefore order is nothing but 2, and whatever the term we have used to decide the order, just find its power. Okay, so what is its power? See, the power of this term is 1 here. Okay, here power is 2, but this is not the highest order derivative term in the equation, this is the highest order derivative term in the equation, and its power is 1, and therefore what, therefore the degree of the equation is, degree of the equation is 1 here simply. Got it? Okay, so in this way we can decide the order on degree of the differential equation. Now we have seen that what is in the order and degree, what is in the differential equation. Now let us talk about the linear differential equation. So what is in by linear differential equation? Linear differential equation. Actually, in previous standard, you have learned about this. Okay, linear differential equation. The linear differential equation means what? The equation, the differential equation whose degree is what, whose degree is 1, strictly 1. This is very important. So whose degree is 1 is called as a linear differential equation. For example, suppose uh, d square y by dx square minus 3y, this is equal to 0. This is linear differential equation. This is a second order linear differential equation, because the order is 2 but degree is 1. The power of this term is 1 here. Therefore this is a second order LDE, linear differential equation. Second order linear differential equation. Okay, so one more example, let us see that. D cube y by dx cube minus 3 d square y by dx square plus 4y, this is equal to 0. What is this? This is third order LDE. Got it? And in general, if we increase the order, okay, so in general nth order linear differential equation will get here. Okay, so here in general, okay, if the order is n, d raised to n y by dx raised to n minus 2 dy by dx, like this is equal to 0. This is what, this is nth order LDE. That definition now we just come to know. Okay, let us see the definition. What is by definition? What is the general form of the nth order linear differential equation with constant coefficient? This is the basic concept. This is the revision that you have learned in the previous standard. Let us see the general form of the linear differential equation. So the general form of linear differential equation is like this. This is important, general form, because our total unit is depend on this general form. Okay, so the general form of LD, nth order linear differential equation. Okay, it is like this. So a naught d raised to n y by dx raised to n plus a1 d raised to n minus 1 y by dx raised to n minus 1 plus a2 d raised to n minus 2 y by dx raised to n minus 2 plus up to this is x. Okay, so this is x plus up to y, this is equal to x. This is a general form of nth order linear differential equation. So here where a naught, a1, a2 up to an are all constant. These are all constants. Okay, and this x is a function of x. So this is x. See, this x is here. Okay, this x should be the function of x. There is no y. Okay, constant should be there, no problem, but the term of y is not there. So this is called as the nth order linear differential equation with constant coefficient. Okay, so see, nth order linear differential equation with constant coefficient, these are the constants and these are all are the coefficients. Got it? Okay, so this is general form of whatever the equation we have now, that throughout this unit it is of this form. Some special type of equations are there also, Cauchy and Legendre equation, but no problem, that also we have to convert in this equation so that we can find out their solutions. Okay, so now let us uh, just try to reduce this equation. Okay, so because every time it is very irritating to write this equation in this form. Okay, d raised to n y by dx raised to n, just little bit we just try to shorten this equation, okay, with the help of operator d. Okay, so it is operator d. What is meant by operator d? Okay, so this is also very important. operator, because we just try to reduce this equation here with the help of operator D. Okay, so now um, put here capital D is equal to d by dx. Okay, so whatever uh, your d by dx, we just replace that dy by dx by capital D. Okay, so this is capital D in this equation number, in equation number 1. Okay, so we just put this capital D, we just replace the d by dx only, yeah? We replace d by dx by capital D. So first of all, just write down the equation and then we replace. Okay, so what is the equation? A naught d raised to n y by dx raised to n plus a1 d raised to n minus y d raised to n minus y by dx raised to n minus 1 plus up to a and y. This is equal to what? Fx. Okay, simply fx. Now what we have to replace? We have to replace d by dx only. So this is d by dx that we have to replace. See here, this is d by dx. Okay, so this is d by dx, only replace this d by dx, remaining is as it is. Okay, so therefore a naught, now it is d raised to n. Okay, I just replace d by dx by d raised to n, then it is y plus a1. Okay, then it is d raised to d raised to n minus 1 into y plus a2, then it is what? D raised to n minus 2 into y plus up to a and y. This is equal to what? Fx. Got it? We have replaced, see, these replacements are d, this is d only, we just replace. Also we just keep the keep also with their keep their powers. Okay, so n minus 1 is here, also n minus 1 is here. Okay, so n is here, also n is here, n minus 1, n minus 2, n minus 3, and so on. Okay, we just keep their power, and we replace only d by dx with the capital D. Okay, now take y common. So what I get here? A naught d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 plus up to an cap bracket complete y. This is equal to fx. See, this is, what is this bracket? This is actually polynomial in D. Okay, this is polynomial in D, and therefore we called it as, for example, suppose let me elaborate this. So if x raised to 5 plus x raised to 4 plus 3x cube plus 4x square plus 5x is equal to 0. This is what? This is polynomial in x, or you can also denote it by 5x. Okay, so this is polynomial in x, this is equal to 0, where 5x is what? This is 5x, where variable is x. Now here same, it is a polynomial in D. So this is polynomial in D, we just therefore uh, considered this as phi of D, because it is a polynomial in D. Okay, so this is what? This is a polynomial in D. This is polynomial in D. Polynomial in D, and therefore we just take this as phi of D into y equal to what? Fx. Phi just the notation. Okay, so don't just get confused with this phi. Why I just take this phi here? So like fx, we just use this fx to denote the function of x. Therefore this phi is also the notation. This is the notation that we have taken. Okay, if we have taken this phi of x is here, then we just use f of d. In some books you can find f of d into y equal to phi of x. Okay, so no problem, you just again take that notation psi, phi, xi. These all are the notations, okay, to denote the polynomial. Or also you can use the that notations in some examples. Okay, so call it as equation number 2. Now this is the equation, this is nth order LDE. Again this is nth order LDE in the form of operator D. This is nth order LDE in the form of operator D. Got it? Okay. So see, this is very important to know this operator D, because see in exam you can find out the example in this form also. Okay. For example, let me take example so that you can understand how we can reduce them in the form of operator D. So 2d square y by dx square plus 3 dy by dx plus 4y, this is equal to 0, suppose. Now here just take capital D is equal to what? D by dx. Okay, now if we take capital D is equal to d by dx, then what happen? So the first equation become 2, then it is d square y plus 3 into dy, sorry, capital D is there, not small d. Okay, it is 3 into dy plus 4y, this is equal to 0. So we can take y common, so 2d square plus 3d plus 4 bracket complete into y, this is equal to what? 0 here. Got it? So now this is phi of x into y equal to 0. Okay, so sometime some function is here, no problem, you can also take the function here. So let us take the function here so that you can understand. Suppose this is e raised to x, this is equal to e raised to x, this is equal to e raised to x, this is equal to e raised to x. Okay, so this is the function phi of d, not x, sorry for this. Okay, so this is phi of d into y equal to e raised to x. So this is your phi of d. So where, what is your phi of d here? Where phi of d is equal to what? 2d square plus 3d plus 4. And what is your fx here? Fx is equal to e raised to x. Okay, so your fx is equal to what? E raised to x. So in this way, we can convert the given equation in the form of operator D also. Okay. Now what is this phi of D? So what is auxiliary equation? This is important to find out the solution. That is the next part of our unit. Okay. So our topic. So auxiliary equation. What is meant by auxiliary equation? Now here consider uh, nth order linear differential equation with constant coefficient. Okay, so if we consider the nth order linear differential equation with constant coefficient in the form of operator d, especially phi of d equal into y equal to fx. So every time I just write in this form, okay, because I'm not writing in the equation in the form of equation 1, general form. This is the general form in the form of operator d. So what is auxiliary equation? If we assign this phi of d to 0, this is what, this is your auxiliary equation. This is your auxiliary equation. Okay. Okay, so because once if you assign this phi of d to 0, then means polynomial in d to 0, it become auxiliary equation. For example, see that we have converted the equation 2d square plus 3d plus 4 into y equal to e raised to x. Okay, so therefore example that we just take 2d square plus 3d plus 4 into y equal to e raised to x. So what is auxiliary equation here? Auxiliary equation is what? 2d square plus 3d plus 4, this is equal to what? 0. This is your auxiliary equation. Okay, so why we just mm, mm, taking all these concept? Okay, because we want the auxiliary equation to find out the solution. Okay, so we can find out the auxiliary equation. We just take the auxiliary equation to solve the example also. Okay, so we just consider that equation. So in this way we just see the definition of nth order linear differential equation, general form of the nth order linear differential equation, and also just introduction of this. So in the next concept is solution of this differential equation. Okay.